Breastfeeding is something that almost everybody has experienced. Mothers, babies, and yeah, probably you at some point. We know that milk is expelled by suckling pressure and the milk ejection reflex. But have you ever wondered why doesn't milk just leak out? To study these characteristics, we use two physical models. The first one is a 3D printed 3-load model. Next, we use a silicone breast model, and this was useful because it had an internal tubing that mimicked the ducts, and we are able to introduce a fluid through an inlet and apply controlled pressure while measuring the outlet. We simulated flow using 3 different geometries. The first one was straight, and this served as our control. The second one was a narrowed duct, and the third one was a branched duct. The straight duct showed smooth, uniform flow all the way through with no disturbance and low resistance. In the narrow duct, the construction in the middle caused an increase in resistance and recirculation zones forming downstream of the pinch point. And for the branched duct, low velocity regions at every single terminal end, which is exactly where the alveoli sit. The geometry alone was creating pockets where fluid just stays, so there was no leakage. Let's talk about duct geometry. According to Poissier's law, the radius is actually the biggest contributor to capillary pressure. To test this, we ran a capillary rise experiment using the radius of 0.85 to 0.5 millimeter. As expected, the smallest radius had the most rise, and using this equation, we were able to see that it produced the greatest capillary pressure. In a simple model, if capillary pressure is greater than hydrostatic pressure, there will be no leakage. However, in this ductal system, there is a lot of branching and narrowing, which only means that capillary pressure is much greater than our model. As we move deeper into the breast, the ducts will narrow and branch until it reaches its alveoli source. Branching reduces flow velocity and increases resistance. This is also consistent with the capillary rise experiment, in which we see that the capillary pressure increases as the radius decreases. Our results are just a couple of explanations for milk retention. However, there may be other contributors such as nipple anatomy and surface tension. You may have known the mechanism in which milk can leave the body, but now you know how the membrane duct can prevent leakage.